Lesson 1.1 is titled Patterns and Expressions. The objective for today is to identify and describe patterns. Right, you can represent patterns in 4 different ways: through diagrams, words, numbers, or algebraic expressions. In problem 1, where we have to identify a pattern, we want to look at the figures from left to right, figure out what the pattern is, and what would the next figure in the pattern look like. So here we have a pattern represented by diagrams. So if we look from left to right, we notice that in our triangle we have 3 sides, quadrilateral 4 sides. We have 5 sides here, that's a pentagon, and 6 sides here, that's a hexagon. So what is the pattern? We're increasing by a side from the figure below, or I'm sorry, from the figure that's to the left. So what would the next figure in the pattern look like? It would be a heptagon. A heptagon is a 7-sided figure. And what does it look like? Looks something like this. Alright, some vocabulary. Quantities whose values do not change are called constants. Examples of what a constant is just any number. So 3 is a number, 10, 200, those are all constants. A variable. Is a symbol, usually a letter, that represents one or more numbers. An example of a variable is usually, you see n, x's, y. Right? Those are all the most common letters used to represent a variable. Okay, the next one. A numerical expression is a mathematical phrase that contains numbers and operation symbols. So it doesn't include variables. So a couple of examples: 3 plus 5, a numerical expression. The quantity 8 minus 2 plus 5, that's also a numerical expression. There's no variables. Right. An algebraic expression is a mathematical phrase that contains one or more variables. So 3n plus 5, or 8x minus 2, plus 5n. Okay, as you can see there, it's an expression, but we have variables written within it. So now that we've reviewed a little bit of vocabulary, before we're going to get to example problem 2, and we're going to be creating a table. And tables are a convenient way to organize data and discover patterns. They work much like an input-output machine, a machine that takes one value as an input, processes it, and gives a value as an output. A process column in the table provides a way to understand what happens to the input values. So this paragraph right here, it just describes the table that we are about to create. Alright, so here we're expressing a pattern with algebra. How many toothpicks are in the 20th figure? Use a table, which I've constructed here, and what you want to construct on your guided notes. Look for a pattern then that relates the figure number to the number of toothpicks. Alright, so this right here is a figure. That's the first figure. This is the second figure, and that's the third figure. So I'm going to write down 1, 2, and 3. Those are our three figures. If we look at the first figure, how many toothpicks are there? Well, there's 4. 1, 2, 3, 4 toothpicks make up the first figure. So I'm going to put that here. If I look at the second figure, 1, 2, 3, 4, 5, 6, 7, 8 toothpicks make up the second figure. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 toothpicks, they make up the third figure. So you can see how we have a pattern emerging. So what is happening? Well, what's happening is we're taking the figure number, and that gets multiplied by 4 to get the total number of toothpicks. So 1 times 4, that gives you 4. 2 times 4, that gives you 8. 3 times 4, that gives you 12. So the pattern is we multiplied the figure number by 4 to get the total number of toothpicks. And so the problem asks, okay, in the 20th figure, how many toothpicks would there be? Okay, so the 20th figure, we're going to write down 20. We're going to multiply that by 4. 20 times 4 gives us 80. So 80 toothpicks are how many toothpicks would be in the 20th figure. Okay. So now we're asked, what is an expression that describes the number of toothpicks in the nth figure? So n is a variable, and n, what does that describe? It describes the figure number. Okay, so we defined our variable n, and so now again we want to write an algebraic expression that describes the number of toothpicks in the nth figure. So what was our pattern? We multiplied the figure number by 4 to get the total number of toothpicks. Alright, so our figure number is n. We're multiplying it by 4. So 4 times the figure number gives us the total number of toothpicks. And this is an algebraic expression that we can use to help us find the number of toothpicks in the 30th figure or the 50th figure, the 100th figure. You just plug in 30, 50, and 100 in for n to get your answer. Alright, so this wraps up lesson 1.1. Again, make sure that your guided notes and the example problems are filled out, because that's what we check to be in class each day.